Hi, I'm Mike Yawn of Hazelcast, back again with another episode of our TelUvision series. This time, we're talking about deployment topologies. There are multiple ways you can choose to deploy Hazelcast. You can deploy us separately from the applications that use it in a client-server fashion, or you can embed Hazelcast directly in your application. It's also possible to deploy in a hybrid manner that combines both of these. We'll look at each of these alternatives. Here's a typical client-server deployment. We have the application and a 5-member Hazelcast cluster. You can write applications that use the Hazelcast APIs directly in any of the languages shown in the left column, or in the right column are some other types of clients we support. If your chosen client is a smart client, it will maintain connections to all cluster members and route requests appropriately. There are also unisocket clients which connect to only a single member, and that member then routes the request to the appropriate target member. We always recommend that cluster members be well matched, so similar hardware, operating system, JVMs, and so on. But the clients don't need to match. So Windows clients connecting to a Linux cluster, that's fine. The other popular deployment option is an embedded deployment. This option is only for Java. The application and a Hazelcast member instance will run in the same JVM. This is a popular option for doing prototyping and development, especially at early stages where only a single member node is needed for testing, as shown here. Here's an embedded deployment with 3 nodes. The embedded members connect and form a cluster, just as non-embedded members would. This topology has the advantage that calls to the local member are local, so no network overhead. But you'll still be reaching across the network for the majority of your operations, since only a portion of the data will be stored locally. A disadvantage of this deployment is that you can't independently scale your application and the Hazelcast cluster. From a developer perspective, it's very easy to update code to use a different deployment topology. The only thing that changes is how you instantiate the Hazelcast instance that you use to invoke the Hazelcast APIs. In a client-server mode, you use a client config object to set any non-standard configuration options and instantiate using Hazelcast client.new Hazelcast client. In embedded mode, you use a config object for configuration and instantiate using Hazelcast.new Hazelcast instance. Now, once you have the Hazelcast instance, all your further calls to Hazelcast are exactly the same. Now, I'll just add one caveat here. It's really easy to change the part of your code that uses Hazelcast to go back and forth between client-server and embedded deployments. But your non-Hazelcast code might be trickier. For example, if you use a singleton object in Java code, you can freely use this anywhere in your embedded code. But if you separate the client from the server, then updates made to the singleton by the client won't be seen by the server, and vice versa. The answer is as simple as taking that Java singleton object and moving it into Hazelcast, where it's accessible from both client and server. But you'll have to modify more of your code to handle that. It's also possible to have a mixed or hybrid environment where there are Hazelcast members that are embedded connecting to members that aren't embedded, as shown here. I've only drawn a few arrows here, but in reality, every member has a connection to every other member. There are 2 additional features that make sense to talk about while we're looking at topologies. One is the light member. A light member is a member that doesn't contain any data. It's useful if you have compute-intensive workloads where you want to bring additional compute capacity to the party, but you don't need to increase your storage capacity. The light member contributes CPU resources to the cluster, but doesn't host any partitions. Light members can be used in client-server, embedded, or hybrid topologies. The final feature is near cache. Near cache allows a member to have a local cache that can help reduce network calls by keeping some data locally. If your workload is mostly read and you tend to reread the same values repeatedly, then near cache can really help boost performance. So, what are the cluster facts we learned today? The topologies supported by Hazelcast are client-server and embedded. They can also be used together in a hybrid mode. From a developer's perspective, calling APIs is the same regardless of topology. Only the mechanism for obtaining a reference to the cluster changes. Light members can be added to any cluster to increase compute capacity. Near cache can be used to reduce network traffic, especially for read-intensive workloads. That wraps us up for today, so see you on the next episode of TelUvision.